we're talking about stoichiometry in solution. Stoichiometry is a method that allows you to calculate each of the measures during a chemical reaction. There are some concepts we need to know before we get into the questions we are talking about today. The first one is a mole. A mole is a measurement of chemical substance. It is include of the Avogadro's number 6.02 times 10 to the 23rd power. For example, we have a mole, 1 mole of water. According to the definition, there are 6.02 times 10 to the 23rd powers atoms in 1 mole of water. The second one is molar mass. It's gram per atomic masses, which means, according to the periodic table, the molar mass of the H2O is 18, which means the weight of 6.02 times 10 to the 23rd powers atoms weighs 18 grams. And the third one, a solution, is a homogeneous mixture composed of 2 or more substances, which means there are a substance dissolved in another substance forms a solution, and the molarity is the moles per liter. Is you dissolve 1 mole of compound into a liter of a substance. And the fifth one, limiting reactant. It is during a chemical reaction. When the chemical reaction is complete, which of the reactant is completely used is the limiting reactant. For example, we have a reaction A plus B equal to AB. When this reaction is complete, B is the first reactant that's running out. So B is the limiting reactant. With all the concepts we just learned, we can solve the first question. The first question is asking, what is the volume of the solution contains 3.12 moles if the concentration of the solution is 6.67 moles per liter. So, in order to solve this question, you have to know we are solving liters when that contains 3.12 moles of the matter. And what we know is 1 liter of the solution contains 6.67 moles. So all we have to do is divide those 2 numbers. We can get 0.468 liters. Now let's look at the second question. This question is said the only item on this list changes as the temperature changes. Now we know molarity is defined as the moles of solute dissolved in a liter of the solution, and we know volumes of everything changes with the temperature. So we can say molarity changes with the temperature. This question is asking us to calculate the volume of 2.75 molarity solutions that must be used to make 1.25 liters of 0.15 molarity of solution. So we need to know how many atoms that contains in the solution. We can simply use 1.25 liters times 0.15. That gives us 0.1875 moles of atoms. So for next part, we need to get the volume of the solution. We already know molarity is defined moles per liter. So we have the moles, just need to punch in the values. We have the moles, now we get the liters. So the molarity is given by 2.75. Now we just only simply use the mole number divide by the molarity. That gives us 0.0681 liters. But remember, the units of this is milliliters. So convert this, we need to divide the final answer by 1,000, which gives us 68.2 milliliters. Now, let's talk about the full response question. So, let's check our given measures. 0.15 grams of sample lead to nitrate is added to 125 milliliters of 0.1 molarities of the sodium iodide solution. Assume no changes in volume of the solution. The chemical reaction takes place in the representing by the following equation. Let's get down to the first question, part A. List appropriate observations provides evidence of a chemical reaction between two compounds. It's asking us what happens when we mix those two reactants. As we can see, the outcome of the reaction is one solid and one aqueous. So we can state a compound, a precipitate is formed during the reaction. While a solid dissolved in the solution. Because the solid is disappearing and new solid forms. For part B, we need to calculate number of moles of each reactant. So we have 0.15 grams of lead to nitrate and 301 grams of the molar mass of lead to nitrate. So we use 0.15 divide by the molar mass, we get the moles. Is 4.53 negative 10 to the negative 4th powers of moles. And we have the molarity of 0.1 of the NaI. And we have 0.125 liters of NaI. So times them up, we have 1.25 times 10 to the negative 2 moles of NaI. Now for part C, we need to identify the limiting reactant. So we need to figure out the amount needed to complete the reaction for each reactant. So we get the first one. The first one, the amount needed is 4.53 times 10 to the negative 4 moles times 2. So the amount needed is 9.06 times 10 to the negative 4 powers moles of lead to nitrate. And from the material given, we only have 4.53 times 10 to the negative 4 moles of lead nitrate. Is lower than the amount needed to react is 1.25 10 to the negative 2 moles of NaI. So the lead nitrate is the limiting reactant. Now for the part D, we need to calculate the molar concentration of NO3. As we know, in this compound, NO3 has 2 times the moles needed. So we have to use the moles of the original compound and times 2. Times 2. Then we divide by the liquid, by the aqueous needed in the volume of the solution, which is 0.125 liters. to the last part. Last part is asking, circle the diagram below of the mixture reactant after the reaction is complete. So it's asking for what's left after the reaction is completed. We all know the lead 2 nitrate is the limiting reactant. So lead 2 nitrate is not our solid. So our solid should be the product, all the product. And we know the amount of NaI is exceed the amount that we needed. So NaI is supposed to be in the solution. So there must be ions. So we got our precipitate and our ions. So the third one is our best choice. Now this is all the material that I'm covering today. Thank you for